What's up, AP Stats? Mr. Zmudio here, continuing with Unit 1, Lesson 1.5. And today's learning objectives, we're going to be dealing with quantitative data today. So remember, we have categorical data and quantitative data. We already talked about some ways to represent categorical data graphically. So today we're going to be talking about how to represent quantitative data graphically. And we also want to be able to describe the characteristics of these data distributions. So mainly we're going to talk about three types of graphic displays. And the first one that I'm sure you guys have seen at some point before is what we call these dot plots. Alright, so a nice thing about a dot plot is that it preserves individual values. And this will make sense when we do an example here in a second. So a dot plot preserves individual values because on the dot plot you can actually see every single value of the data. This gives you a nice shape of the distribution. So you should be able to see just how spread out all the data is by looking at the dot plot. We're also going to talk about a stem and leaf plot, which some of you also may have seen before. And this one pretty much does the same thing. So it preserves individual values and it gives you a nice shape of the distribution. And the last one we're going to talk about today is a histogram. And the histogram does not preserve individual values. Now, we would rather have individual values than not have them and not be able to see them. So some of you may ask why histograms why are they even a thing? Why wouldn't we just use a dot plot and stem and leaf plot? Histograms work better when you have large amounts of data. So if I had data that we were talking about like 1,000 different numbers, a histogram would definitely be the better display to choose. All right, so histogram, I'm going to put the word bins here, and we will see what these all mean in a second. So first, let me give you a little example. There are 10 kids in my AP Stats class, and I wanted to see how they did on a recent test. And those scores out of 100, that is a terrible marker. Those scores out of 100 were 63, 79, 83, 84, 85, 86, 88, 89, 92, and 99. We have quantitative data here. As we see, we're talking about percentage points. And we're going to take these 10 points, these 10 quantitative points, and we're going to represent them graphically using a dot plot, stem and leaf plot, and then a histogram. Well, let's first do the dot plot. For the dot plot, you want to have sort of like an x-axis where you start off with your smaller numbers and then work your way up. So I see my smallest number is 63 and I go all the way up to 99. There's no right or wrong way to do this. I'm going to start at 60 and maybe go by fives all the way up to 100. Again, no right way to do this. Definitely could have used a different scale here, but I think working with fives might be easy for now. So we have 60, 65, 70, 75, 80, 85, 90, 95, 100. Now what I'm also going to do is I'm going to change the colors here. And I'm going to go in between each of these and add 4 little lines. So 61, 62, 63, 64. Now, please don't feel like you have to do this right now. I'm doing this just for learning purposes. I think you guys will be okay if you don't copy this dot plot down. Right, and then a dot plot basically is going to be for every point that you see, put a dot on your dot plot. So the first value was 63. I'm going to find 63, and I can put a little dot right above 63. We also have a 79. So I'll find 79 right there, 83, 84, 85, 86, 88, 89. So there's one little gap right there. 92 and 99. So I do want to mention that none of these points repeated, actually. We had 10 different numbers. But if there was a repeat, for example, let's say there was 2 kids that got this value of 79. To show that, you would just stack the dots on top of each other. This shows you that 2 kids here got 79. But for the data that I gave you, there was no repeats. So with dot plots, the reason we talk about preserving individual values is just by looking at this display, you can tell what scores each of these 10 kids got. Right? By looking at this last one over here, I know the student got a 99. By looking at this one, I know the student got a 63. And since I did this by hand, it's not always going to be the neatest, which is something it's okay in statistics. If possible, we'd rather use technology to create these displays. One thing that is going to be missing from this is that we need context. I can't just give you guys naked numbers, and in the same way, I can't give you guys just naked graphs. So what are we talking about? And in this case, we're talking about scores on stats test. All right, so stem and leaf plot. A stem and leaf plot will look like something like this, where this left side is the stem and the right side will be the leaf. Sorry about that. Now, when I say stem and leaf, really looking at each of these individual values, you're essentially breaking this up into 2 pieces, where one side is the stem and the other side is the leaf. And what this does is it kind of lets you see how many of these values are in the 60s, how many of these values are in the 70s, how many are in the 80s, and so on. So on the right side, I just have a 3. There's only one value there for the 60s. In the 70s, I also only had one value. And 80s, I start to see a lot more here. All right, so we have 83. And then to show the 84, you can just put a 4 on the outside of the 3 there. And you continue that pattern. So then we have 85, 86, 88, 89. There was no 87, so that's why I skipped 7. And we can see that we have a lot more values in the 80s than we did in the 70s or 60s. 90s, we have 92 and 99. And then we have a nice little stem and leaf plot. Now, I do want to say that I decided to make my scale by 10. That's something that can also change. And I'll do a very quick one right below here. I could have made my scale by 5s. So here's what this would have looked like. Maybe any value from 60 to 64, so that's 5 digits, right? 60, 61, 62, 63, 64, would go in this first 6. The second 6 would have the values 65, 66, 67, 68, 69. And if we repeat this pattern with the 70s, 80s, 90s, this is a little more descriptive in that you can see the shape a little better. So 63, the 3 would go in the first one. Right, the first one over here is from 60 to 64. I had nothing in the second half of the 60s. I had nothing in the first half of the 70s. And then our next value was a 79. Then we have the first 8 representing 80, 81, 82, 83, 84. We had no 80s, we had no 81s, no 82s. We had 183 and 184. The second half of the 80s, we have a lot more values. We have 85, we have 86, we have 88, and we have 89. Now for the 90s, we have a 92, and then we have a 99. So both of these are stem and leaf plots. I like to think that the more you break down your data, you get a better description of what it looks like. But again, this just depends on the person. With these, it is important that you add a little key. So here's what this looks like. My key. Let whoever you're talking or whoever is grading your work know that just pick any of these values. So let's say this means 63. You're basically letting the grader know that the line here, you're separating your 10s and your 1s. That's it. And if I made one for up here, again, I could pick like any number I want. So something like this. Right, so stem and leaf plot, you can see the shape of the distribution. So here we can see that most of our data lives in like the 80s, a little bit in the 90s, and we have this 63 that's pretty far out from the rest of the data. And similarly, in the dot plot, you can also see that most of the data is kind of clustered around this mid-80s, and then we have one kind of high value and one really low value. So that's what's nice about dot plots and stem and leaf plots. You can see the shape of the distribution and just how spread out all the data is. And you can see each individual value. Like I said over here, you can see all 10 dots. And if my graph was better, you could see what each of those dots actually represents. And on a stem and leaf plot, you can tell exactly what each number is, right? We know we have an 83 and an 84, 85, 86, 88, 89, and so on. Now, a histogram does not preserve individual values. And that's because in histograms, we group all these data into bins. So a histogram is like a bar chart. It looks like a bar chart, but it's actually not a bar chart. And we'll see that example over here. So I'm going to erase, no I won't. So with histograms, we want to look at ranges of values. And I see that our lowest value is 63, our highest is 99. So I'm actually going to decide that my bins are just going to be in the tens place. And that means that I'm going to start off in the 60s. And go up by tenths. All right. Now on the left side for histograms, you should always see the word frequency. Frequency, or sometimes you'll see counts. Basically, how many times did it happen? So, with a histogram, 3, 4, 5, 6, 7, the left side tells you how many times did you get a value that fits inside of that bin. So this bin right here, this first one, 60 to 70, this is actually 10 numbers, and it starts with the lowest one right here, which is 60. So it's 60, 61, 62, 63, 64, 65, 66, 67, 68, and 69. 70 is not actually included in this first bin. 70 marks the start of the next bin. So I'm asking you guys, how many pieces of our data were between 60 and 69? Well, that just happened one time. It was 63, right? So the frequency was just 1. So the size of this bin is just 1. All right, my second bin from 70 to 80, really 70 to 79, how many values did I have that were in that range? Just 1. So this bin is going to be the exact same size as the first one. Now the second bin, 80 to 90, we have a lot of values between 80 and 89. 1, 2, 3, 4, 5, 6. So the frequency for this guy is 6. And because I'm doing this by hand, and like I said, a lot of times when you do stuff by hand, it doesn't end up so neat. You can actually help the grader out, or whoever it is, by just putting the number on top. That way they know. So like this frequency right here should line up with 6 over here. And if I wanted to do it for these also, it's just 1 and 1. Right now, how many did we have in the 90s? So 90 to 99. We had 2. So the last bin, there's a frequency of 2. So notice that there is no space between any of these bins. All right, that's how a histogram works. And notice that a histogram is a range of values, right? So this 1 over here means that there's one data between 60 and then 69 that's in here. When I said earlier that this does not preserve individual values, what I meant by that is if you just looked at this histogram and you didn't know this data up here, there's no way you can tell what the 10 scores were from these students. Like, we know that there's 2 kids that scored in the 90s, but just by looking at the histogram, you have no idea what those 2 scores were. It could have been a 99 and a 99. Could have been a 91 and a 96. Or whatever other combination you want. That's what we mean when we say it does not preserve individual values, which is kind of one flaw, I would say, of a histogram. But again, like I mentioned before, that's why we prefer to use histograms when we're working with larger data sets. So right here we have just 10 pieces, but imagine if we were working with something that was like 1,000. Histograms definitely help describe the shape of the distribution better by breaking up the data into what we call bins. Alright guys, so that's it for today. Dot plots, stem and leaf plots, histograms. If you didn't get all these notes down, not a big deal. But these 3 things will be coming back up the rest of the year. This is just like the